Have you ever been there? You've built this awesome 2D world in Unity, you've got your character all set up, but when you hit play, they just sit there. You want them to slide down a cool ice slope or ride a moving platform, but they're just stuck. Now you could spend hours, maybe even days, writing a bunch of complicated physics code to make it work. Or you could use one of Unity's most powerful and honestly most overlooked components. Today we're going to pull back the curtain on the secret to creating totally effortless motion, the surface effector 2D. Let's get right into it.
So here's the plan for today. First, we're going to look at that classic static player problem. Then I'll introduce you to Unity's secret weapon for motion, which you'll see is basically just a conveyor belt. After that, we'll walk through a super simple 3-step process to get it working. We'll fine-tune the settings to get that ride just perfect. And finally, we'll look at all the other cool stuff you can do with this amazing tool. It's going to be a fun ride from stuck to sliding, so let's get going.
All right, let's kick things off with a situation that I'm sure is familiar to a lot of you out there. I call it the static player problem. You've got the world, you've got the character, but where's the motion?
Okay, so meet Barry. Barry is our snowboarder. We've dropped him onto this pretty nice-looking snowy slope. We hit the play button and, well, absolutely nothing happens. He's just parked there. So why? Well, if he had a simple circle collider, he'd just roll down the hill naturally. But our character uses a flat-bottomed box collider, and there's just enough static friction to keep him locked in place on this slope. So the big question is, how do we get him moving like a real snowboarder without having to write a ton of code?
Look, we absolutely could go down that rabbit hole. We could start writing scripts to apply force. We could mess with the physics materials and friction. We could tweak gravity. There's a whole bunch of ways to tackle this with code. But man, that gets complicated and it's super time-consuming. Instead, we are going to use a much more elegant solution that Unity gives us right out of the box.
So what is this magic tool I'm talking about? Well, let's jump into our next section and meet the hero of our story today, the Surface Effector 2D. You can think of this thing as Unity's built-in conveyor belt, and I promise it's going to completely change how you approach movement in your games. So what is this thing, really? Let's start with the official, kind of technical definition from Unity. It says the Surface Effector 2D applies tangent forces along the surface of a 2D collider. Okay, tangent forces. That sounds a little dense, right? What does that actually mean for us in our game? Well, luckily, Unity's own documentation gives us the absolute perfect way to think about this. Just forget the words tangent forces and think of one simple thing: a conveyor belt. That is it. That's the whole idea. When we add a surface effector to an object, we are literally turning its surface into a conveyor belt. Anything with a rigid body 2D that touches it will get pushed along. It's such a simple and powerful concept. Now, it's worth pointing out that the surface effector isn't some lone wolf component. It's actually part of a whole family of 2D effectors in Unity that can do all sorts of cool things, like create tractor beams, or one-way platforms, or even simulate water physics with buoyancy. They are all incredibly useful, but for today, we are putting all of our focus on mastering our new best friend, the Surface Effector 2D. Okay, enough theory. It is time to get our hands dirty and actually put this thing to work. And I promise you, this is going to be so much easier than you think. We are going to get Barry moving in just 3 simple steps. Let's do it. Here's the entire game plan at a glance. It's super simple. First, we just add the Surface Effector 2D component. Second, we need to find the specific collider that's acting as our ground. And third, we just have to tell that collider, hey, I want you to use the effector we just added. Let's break down each one. All right, step 1. Now, the most important thing to remember here is where you add this component. Your first thought might be to put it on the player, but that's wrong. The effector has to live on the surface that's actually doing the pushing. So right here in the Unity editor, I'm going to select my level object. You can see it's called Level Sprite Shape in my hierarchy. Then I'll go over to the inspector, scroll all the way down, and click Add Component. I'll just start typing Surface Effector 2D. There it is. Click it. And boom. That's it. The component is now attached to our level. Okay, so that was step 1. But before we get to step 3 on the slide, we have to do step 2, which is finding the right collider. So if I look at my level sprite shape object here in the inspector, you can see the component that actually defines the physical ground our player stands on is this one, the Edge Collider 2D. This is what the surface effector needs to use as its conveyor belt. And that leads us to our final and totally critical step 3. Right on that same Edge Collider 2D component, you'll see this little checkbox that says Used by Effector. It's off by default. We just need to check that box.
This is what creates the connection. It tells the surface effector, hey, use this edge as a conveyor belt. And with that checked, our setup is actually done. So we've added the component, we've linked it to our collider, we hit play, what's going to happen? Hey, we have movement. Look at that. Barry is no longer just sitting there, he's actually sliding along the surface. But man, is he moving slowly. It's more like a lazy crawl than a snowboard run. So we've done it, the concept works, but it's not quite right yet. And this leads us perfectly into our next section. So we have motion, but now we need to take control. This next part is all about refining those settings, troubleshooting some common problems, and turning that slow, sad crawl into a really smooth, awesome slide. So how do we fix that painfully slow speed? Well, this one is super straightforward. Let's go back to our level object in the inspector and look at the surface effector 2D component we added. You'll see the very first setting is speed. By default, it's just set to 1, which explains the slow crawl. To make Barry move faster, all we have to do is crank this number up. I'm just going to click in here and change it from 1 to, say, 20. And now, when I hit play, there we go. That's what I'm talking about. Barry is now cruising down the hill at a much more respectable speed. But wait, as you might expect, as we crank up the speed, a new and honestly much more annoying problem can show up. As Barry starts zipping along, he might suddenly get snagged on a sharp corner, or even worse, he might just completely fall right through the ground into nothingness. The effector is doing its job, but now our physics engine is struggling to keep up with the new speed. So what's the fix for that? The solution for this isn't on the level. It's actually on our player, Barry. So I'll select the player object, and in the inspector, find his rigid body 2D component. We're looking for a property called collision detection. By default, this is set to discrete. Now, discrete is fine for performance, but it only checks for collisions at specific moments in time. If your object is moving fast enough, it can literally pass all the way through a wall between those checks. It's a bug we call tunneling. The fix is to change this setting to continuous. Now, there is a trade-off. Continuous collision detection uses more CPU power, but it's way more accurate, and it stops that tunneling bug dead in its tracks. For your main player character, trust me, that little bit of extra processing cost is almost always worth it for a bug-free experience. Okay, now that everything is stable, let's talk about the two most important settings you're going to be playing with: speed and force scale. We already know speed is how fast that conveyor belt is moving. A positive number pushes Barry forward, and as you can see in the example, a negative number like -10 will actually run the belt in reverse and push him backward up the hill. Now, force scale, that's a little different. It's about how strongly that speed gets applied. It's like the muscle behind the movement. So if you have a really steep hill, gravity is fighting you. A low force scale, like 0.01, might not have enough oomph to push Barry up that hill. But if you crank up that force scale, the effector's push becomes way more powerful and it can easily overpower gravity. So remember, speed is the velocity and force scale is the power. We did it! We've implemented the effector, we've fine-tuned it, and we have a smooth ride. So now let's wrap this all up by going over the most important points and talking about how you can take this whole concept even further in your own games. So here are the absolute must-remember takeaways. First, the effector only works when your character is physically touching that collider. The second you jump, it has zero effect, which is exactly how you'd want it to work. But most importantly, and this is where the real power comes in, remember that these values you see in the inspector aren't locked. You can access and change every single one of these properties, like speed and force scale, from your C# scripts. This is where things get really fun. Think about it. You could have the player hit a boost pad that calls a bit of code to temporarily double the effector's speed. Or they could run into a patch of sticky mud that sets the speed way down. The possibilities for creating these dynamic, interactive surfaces are just endless. And that just about brings us to the end. You now have this incredibly powerful, super efficient tool in your Unity toolkit for creating all kinds of amazing surface-based movement, and you didn't have to write a single line of complex physics code to do it. From slippery ice patches to factory conveyor belts, from flowing water currents to futuristic transport tubes, the only thing limiting you now is your own imagination. So the question I'm going to leave you with is this: what are you gonna build? Thanks for tuning into this explainer, and happy coding.